Have you ever stopped to think about the hidden tech that really powers our modern world? Well, there's this invisible force at play in, well, pretty much everything, from heavy industry to our own homes. And today, we're going to pull back the curtain on the machine that makes it all happen.
So let's start with a little puzzle. What could possibly connect the powerful brakes on a huge train, the superfine mist from a painter's spray gun, and maybe even the fridge keeping your food cold? I mean, they seem totally unrelated, right? Well, turns out they all share a surprising secret.
The answer is all about an invisible force that is, and I mean this quite literally, everywhere around us. It's a utility you've probably used 1,000 times without even realizing it. And the answer is compressed air. The sheer variety of things it does is what's truly mind-blowing. We're talking about the raw power needed for pneumatic drills that tear up a street, but also the delicate precision for a paint sprayer. It's the critical safety system in the air brakes of buses and trains. It's the brute force that kicks over massive jet and diesel engines. It even powers blast furnaces. It really is a fundamental part of our entire industrial backbone.
So, what's creating this incredibly versatile power source? Well, the hero of our story is this machine right here, the air compressor. It takes the simple air we breathe and turns it into an incredibly powerful tool.
But how does it actually do that? I mean, how do you squeeze air to make it so useful? Let's dive into the mechanics of how these amazing machines actually work.
Okay, so the formal textbook definition tells us a compressor is a device that increases a gas's pressure by doing work on it. And that's a really key point. It doesn't create energy out of thin air, it transfers energy into the gas, basically just packing all those air molecules closer and closer together.
And what that really means is, at its heart, it's a work-absorbing device. It needs a power source, like an electric motor or a gas engine, to do all the heavy lifting. It's taking that rotational energy from the motor and converting it into the potential energy that's stored in the pressurized air.
All right, to see how this all works in practice, let's take a look inside the most common type you'll probably ever encounter, the reciprocating compressor. This thing is the real workhorse of the compressor world.
Now, here's a great way to think about it. If you kind of get how a car engine works, using tiny explosions to push a piston and turn a crankshaft, then you can totally get this. A reciprocating compressor does the exact opposite. It uses a turning crankshaft to drive a piston and compress the air. Simple as that.
And the key players here? They should look really familiar. You've got a piston that moves up and down inside a cylinder, and it's all driven by a connecting rod and a crankshaft. Then, up at the top, you have these two really important one-way doors, a suction valve to let the air in and a delivery valve to let all that compressed air out.
Okay, let's put those parts in motion. It's really just a four-step dance. First, you have suction. The piston moves down, that inlet valve opens up, and regular air gets drawn into the cylinder. Second, compression. The inlet valve closes, the piston travels back up, and it squeezes that trapped air, which just skyrockets the pressure. Third, delivery. Once the pressure gets high enough, it forces the delivery valve open, and the piston pushes that high-pressure air out into a storage tank. And finally, expansion. A tiny bit of high-pressure air that gets left behind expands, the pressure drops, and the whole cycle just starts right over again. Suction, compression, delivery, expansion. Over and over.
Now, the reciprocating compressor we just looked at is part of a bigger family. Compressors are generally sorted into two major categories, and it's all based on how they get the job done.
So, on one side you have positive displacement compressors, like the reciprocating one we just talked about. Their whole strategy is to trap a set amount of air in a chamber and then just mechanically shrink the size of that chamber to crank up the pressure. This method is amazing for creating really, really high pressures. On the other side, you've got dynamic compressors. These work totally differently. They don't trap the air. Instead, they use a super fast spinning impeller to kind of fling the air outwards, which adds velocity that then gets converted into pressure. Think of it like the difference between squeezing a balloon versus using a giant fan to create a powerful gust of wind. Dynamic compressors are awesome for moving massive volumes of air, just usually at lower pressures.
So we've seen how they work and all the incredible jobs they do. But now let's zoom back out and try to wrap our heads around the true global impact of this invisible force.
And wow, this is a truly staggering figure. About 10% of all the energy used by industry all around the globe goes into doing one thing, compressing air. This isn't some niche technology, it's a massive energy-hungry utility that props up modern manufacturing and infrastructure.
So that leaves us with a pretty critical question, doesn't it? This invisible force is absolutely essential, but it comes at a huge energy cost. As we rely on it more and more, the real challenge becomes about efficiency. How can we innovate these incredible machines to do the same vital work, but with a much smaller, more sustainable energy footprint? Now that's the next big chapter in the story of the air compressor.